Welcome back to The Deep Dive, where we unpack the most crucial information out there, giving you the shortcut to being truly well-informed. I'm your host, thrilled to have you joining us today for what promises to be a fascinating exploration. And before we dive headfirst into today's insights, if you're as curious as we are about the world around us and want more deep dives like this, make sure to hit that subscribe button to hear more about this world.
Okay, let's unpack this. Today, we're zeroing in on a genuinely pivotal development in the world of sustainable building. We're talking about the new AEV5 credit, specifically and intensely focused on reducing embodied carbon in construction.
That's right. It's a huge shift.
It really is. And this isn't just another piece of industry jargon, is it? It feels like a critical strategic shift in how we think about the environmental footprint of our buildings.
Absolutely. It goes right from the foundational materials, the concrete, the steel, all the way to, well, the final finishes. So we're going to explore not just what this new standard demands, but how it's fundamentally reshaping design processes, pushing the construction industry towards more responsible, more innovative practices.
And ultimately more sustainable practices. It's really about changing the whole approach.
It's a deep dive into the very nuts and bolts of greener building, and frankly, it's pretty exciting stuff. So let's start with the fundamental question, because for many, embodied carbon might still feel like a newer concept compared to, say, energy efficiency, which we've talked about for decades.
Right. Operational energy has been the focus for so long.
Exactly. So what is embodied carbon really, and why has it become such a significant focus for new forward-thinking standards like LEED 5? Why should you, our curious learner, care about it, especially when we've spent decades perfecting operational energy efficiency? It feels like a big shift in priorities.
That's an excellent, indeed a crucial starting point, because it truly redefines how we measure a building's total environmental impact. You're absolutely right. Historically, our focus was heavily on operational carbon.
Heating, cooling, lights.
Exactly. The emissions from running the building once it's up. But the conversation has dramatically broadened. It had to. The intent of this new credit, it's known as MRc2 within LEED v5, is clearly stated and, honestly, pretty ambitious.
Okay.
It says, to track and reduce embodied carbon of major structural, enclosure, and hardscape materials from construction processes on new construction and renovation projects.
Right. Track and reduce. That's key.
Precisely. So, to put it simply, embodied carbon refers to all the greenhouse gas emissions associated with the materials that go into a building across its entire life cycle before it even begins operating.
Before day one.
Before day one. Think of it as the carbon debt incurred up front. It's already baked in. We're talking about a comprehensive accounting of emissions here. This includes the initial extraction of raw materials. Imagine the energy and emissions involved in mining iron ore for steel.
Or quarrying limestone for cement, logging for timber.
Exactly. Then there's the incredibly energy-intensive manufacturing and processing phase, turning those raw materials into the finished products we actually use.
Like steel beams, concrete slabs, glass.
Glass panes, insulation, bricks, you name it. Many of these industrial processes, particularly for cement and steel, are massive emitters, huge sources of CO2.
Right.
After manufacturing, these materials need to be transported, often across vast distances, ships, trains, trucks, to the construction site. That adds further emissions from fuel consumption.
So the journey matters too.
Definitely. And finally, the installation on site itself. That involves machinery, cranes, excavators, temporary power for the site, maybe site heating in cold climates.
Yeah.
All that contributes to that upfront carbon footprint.
Wow.
All of this, from cradle to gate, basically extraction through manufacturing and often even beyond, contributes to a building's embodied carbon footprint.
So it's not just about the finished product we see, but every single step of its journey to get there. That distinction between operational and embodied carbon is really clear now. But I'm still curious, for an industry that's often very cost sensitive and has been so focused on operational energy savings for so long, what's driving this pivot?
Yeah.
Why is embodied carbon suddenly taking center stage right now?
That's the million-dollar question, isn't it? And it's really a confluence of factors.
Yeah.
First, the sheer scale. The construction industry is a massive global player in emissions.
Huge.
It's estimated that buildings and construction are responsible for nearly 40% of global energy-related carbon emissions. That's enormous. And a significant chunk of that, roughly 11% of total global emissions, comes directly from embodied carbon.
11% globally just from the materials and construction.
Just from making the stuff and putting it together, essentially, before the lights are even switched on. That's a staggering figure we just can't ignore anymore if we're serious about climate goals. The second reason, and perhaps the most strategic one, is that as we've gotten better at making buildings operationally efficient,
Right. Better insulation, smarter systems.
and as our electrical grids become progressively greener, with more renewables coming online,
Yeah.
the proportion of embodied carbon in a building's total life cycle emissions has drastically increased. It becomes the bigger piece of the pie.
Ah, so as operational carbon goes down, embodied carbon looms larger, relatively speaking.
Exactly. In some highly efficient renewable-powered buildings, embodied carbon can now account for 50% or even more of the total carbon footprint over its entire lifespan.
50% or more. Wow.
Yeah, it's like we've really improved the fuel efficiency of the car, but now we have to look at the carbon costs of manufacturing the car itself. It's the same principle.
That makes sense.
And for climate goals, especially those targeting net zero by 2050, we need to address emissions now. We can't wait. And embodied carbon is that upfront carbon investment. If we don't tackle it early in a building's life, we lose that window of opportunity forever for that building.
You can't really retrofit embodied carbon out later.
Precisely. This EEV5 credit is specifically designed for new construction and renovation projects because that's where we have the greatest leverage to make these upfront changes. It's about ensuring that from the very beginning, we're setting a foundation for truly sustainable structures.
That makes perfect sense. We've been so focused on the running costs, the operational side, that we sometimes forget this massive upfront investment in carbon before the building even opens its doors. It's truly a critical shift in perspective. So if a project team wants to be a leader here, wants to really lean into this, how does it actually get credit for reducing this embodied carbon? What's the game plan and what are the rewards for taking this on, given it sounds pretty complex?
Well, the credit structure itself signals the immense importance LEV5 places on this issue. This is an MRc2, that's Materials and Resources Credit 2, and it offers possible 6 points.
6 points. That's a lot in the LEED system, isn't it?
It's substantial, yeah. For a single credit, 6 points is a big deal. It immediately tells project teams that this isn't just some minor add-on, it's a core component. It's potentially a game changer for achieving higher levels of certification, especially for those aiming for gold or platinum.
Right, those top tiers.
It shows a serious commitment to transforming the project's environmental impact right from the ground up. And for projects truly aiming for that highest certification, platinum, there's an even higher bar. They need to demonstrate a 20% reduction in embodied carbon across the board, minimum.
20% reduction minimum for platinum, wow.
Yeah, this isn't just about making small incremental improvements. It signifies a really ambitious commitment. It often requires significant innovation in material selection, structural design, really rethinking how things are done.
Okay, so how do they actually do that? What needs to be included in the calculation?
To earn these points, projects need to meticulously quantify the reduction of embodied carbon for major structure, enclosure, and hardscape materials. Let's break that down because it's quite comprehensive. Major structure. This is the skeleton, the bones of the building foundations, columns, beams, floor slabs.
The heavy stuff.
The heavy stuff, exactly. And these are typically the largest contributors to embodied carbon, mainly due to materials like concrete, cement production is very carbon intensive, and steel.
So what can teams do there?
Well, they might explore alternatives like mass timber structures, or using high recycled content steel, or specifying innovative low-carbon concrete mixes, which are becoming more available now.
Interesting. Okay, what about enclosure?
Enclosure. This refers to the building envelope, the skin. So exterior walls, roofing, windows, doors.
The bits that keep the weather out.
Right. And these materials are crucial for both operational energy performance and aesthetics, but they also have significant embodied carbon. Think about the emissions from manufacturing glass, aluminum window frames, various insulation types, cladding materials. It all adds up.
Okay, and hardscape, that's the outside stuff.
Hardscape materials. Exactly. This covers elements like paved areas, walkways, courtyards, parking lots, other constructed surfaces within the project boundary.
Things we might overlook sometimes.
Often overlooked, yeah.
Yeah.
But the concrete or asphalt used for these elements can add up significantly, especially on larger sites. So projects might consider things like permeable pavers, using recycled content aggregates in the asphalt or concrete, or even just maximizing natural landscaping instead of paving everything.
That makes sense, looking at the whole site.
And what's fascinating here, and really shows a holistic view, is that the scope extends beyond just the main building itself.
Oh.
The requirements explicitly state that all ancillary structures, such as parking structures or outbuildings within the LEED project boundary must be included in the calculations.
So a separate parking garage counts too.
Absolutely. If it's within that defined LEED boundary, it has to be included. This means no significant carbon sources are overlooked. It encourages teams to think about the entire site's impact, not just the primary structure. It really connects the dots across the whole development.
That's quite comprehensive. How do they quantify the results? Do they have to wait until it's built?
Good question. Projects actually have some flexibility here. They can use either as designed or as constructed final quantities.
Okay, so based on the plans or based on what was actually used?
Right. They can model the carbon impact based on initial plans and specifications, which helps in early design decisions. Or they can verify it once construction is complete using actual purchase orders and installed quantities, which is obviously more accurate to the final product.
But what if things change during construction? That happens all the time.
It does, and there's a crucial caveat for that. The quantities cannot change more than 10% from design through construction.
Ah, okay, a 10% buffer.
Exactly. This rule is smart. It prevents projects from, say, designing with low-carbon materials on paper to get approval and then swapping them out for cheaper, higher-carbon alternatives during construction without a reevaluation.
Keeps everyone honest.
It does. It ensures that the initial design assessment remains largely representative of the final product and holds teams accountable for their original embodied carbon goals. Ultimately, the rule is that the results must be based on embodied carbon intensities of materials as constructed, emphasizing real-world performance.
Got it. So the points are based on reducing the GWP, the global warming potential. How does that point system work? You mentioned table 1.
Right. The points are awarded based on those reductions in GWP, which is our main metric of carbon emissions, measured in kilograms of CO2 equivalent, or kJ-CO2e.
Right.
Projects can earn these points through a few different options, which are detailed in table 1. This table basically lays out how different levels of GWP reduction and the specific pathways or options you choose to follow earn between 1 and 6 points.
Okay.
And it's also important to note something else mentioned there. Simply meeting a baseline or an industry average value, while maybe a good first step, can achieve no more than 2 points.
So just being average doesn't get you much credit.
Exactly. This clearly nudges projects towards actual demonstrable reductions. It rewards them for going above and beyond the status quo and really pushing the envelope of current practices. It's not enough to just be average. LEV5 is demanding leadership here.
It really sounds like LEV5 is raising the stakes and demanding verifiable, impactful change. That feels necessary for truly sustainable building.
It absolutely is.
Now, you mentioned different options for earning points. Let's really dig into those. Option 1 sounds like the big one, Whole Building Life Cycle Assessment, or WBLCA. What exactly does that involve? It sounds like an incredibly massive undertaking, almost like an environmental MRI for a building.
That's a great analogy. An environmental MRI is spot on. You're absolutely right. Option 1, the WBLCA, is the most comprehensive route. And because of that, it's where a project can earn the most points, between 3 and 6 points, for demonstrating significant reduction.
3 to 6 points just for this option.
Okay. Yeah. This option focuses on the entire life cycle of the project's structure, enclosure, and hardscape materials, those core components we just discussed. When we talk about WBLCA, we're talking cradle to grave. This means it covers the entire journey of building materials and components. Let's break down those stages. Module A, product stage, cradle. This is where materials are extracted from the earth or harvested, transported to factories, and then manufactured into finished products. Think cement production, steel milling, timber processing, all that upfront stuff.
Got it.
Module A5, construction process. This includes the transport of those finished materials to the construction site and the energy used during their actual installation.
Okay.
Module B, use stage. Now this covers maintenance, repair, replacement, and refurbishment over the building's operational life.
Sure.
Critically, the operational energy itself is excluded, but the embodied carbon of replacing materials, say a new roof after 30 years, is included.
So the materials used during the building's life count too.
They do. And finally, Module C, end-of-life stage, grave. This is the final chapter: demolition, transport of waste materials, waste processing like recycling or incineration, and eventual disposal in landfills. The whole endgame.
Cradle to grave, that is comprehensive.
It is. And what's crucial to understand here, and a clever distinction by LEB5, is what's excluded from this cradle to grave scope for the purposes of this credit. operating energy, and operating water-related energy.
Right. You mentioned that. Keep it focused on embodied.
Exactly. Keeps the focus razor sharp. The WBLCA in this context is specifically looking at the environmental footprint of the materials themselves and their journey: extraction, production, transport, construction, replacement, disposal, not the energy used to run the building day to day. So you're analyzing the emissions embedded in the concrete, the steel, the wood, the insulation, the roofing, all the physical stuff, and its full life cycle.
Okay, so you do this massive analysis. How do you know if you've reduced it enough to get points? What are you comparing against?
Good question. The results of this WBLCA are then compared to a baseline developed for the project. This isn't just comparing your project to some generic average building out there.
No.
No, it's about establishing a rigorous project-specific comparison point. Typically, this baseline is a sort of conventional design alternative for the same proposed building.
The same building, but built standardly.
Exactly. Designed to the same functional requirements, same size, same local codes, but using standard, non-optimized materials and construction practices common in that region. This allows for a true apples-to-apples comparison, so you can accurately measure the impact of the sustainable choices you actually made.
That makes sense. That baseline is your benchmark.
Precisely. And earning points is directly tied to the percentage reduction in global warming potential, or GWP, compared to that baseline, as outlined in Table 1.
And the points scale up.
They do. Achieving a 10% reduction in GWP gets you 3 points. Then it steps up, maybe 20% gets 4 points, 30% gets 5, and hitting a 40% or greater reduction nets the maximum 6 points for this option.
40% reduction is huge.
It's very significant. Achieving that often means rethinking fundamental design choices. Maybe opting for mass timber over concrete for the main structure, or using really innovative low-carbon concrete mixes throughout, or drastically reducing material quantities through efficient design. It demands creativity and a deep understanding of material science and life cycle impacts.
It really does sound like an environmental genome scan for a building, analyzing every strand of its material DNA. It's incredibly thorough.
It is.
But you mentioned earlier that it's not just about GWP, the carbon footprint. You said, here's where it gets really interesting. What are some of those other critical impact categories that a WBLCA must assess? Why is it so crucial that LEED v5 pushes beyond just single metric thinking, forcing projects to avoid maybe carbon tunnel vision?
Absolutely. This is one of the most brilliant aspects of the WBLCA requirement in Option 1. It forces a truly holistic environmental assessment. It prevents a situation where a project might, say, reduce carbon, but inadvertently increase water pollution or resource depletion somewhere else. You solve one problem, but create another.
Right, shifting the burden.
Exactly. So the WBLCA report isn't just about GWP. It must include results for 6 crucial impact categories. Each of these tells a different vital part of a building's environmental story. 1. Global warming potential, GWP. This, of course, is our central climate change concern. Measured in kilograms of CO2 equivalent, kg CO2e. It accounts for CO2, methane, nitrous oxide, etc. This gets the most attention, understandably.
Okay, number 1.
2. Depletion of the stratospheric ozone layer. Measured in kilograms of CFC11 equivalent, kg CFC11e. This tracks emissions that damage Earth's protective ozone layer, which shields us from harmful UV radiation. Still important to monitor, even with progress like the Montreal Protocol.
Right, that ozone hole issue.
3. Acidification of land and water sources. Measured in moles of H+ or kilograms of SO2 equivalent, kg SO2e. This looks at things like acid rain caused by pollutants like sulfur dioxide and nitrogen oxides from industrial processes. It harms ecosystems, corrodes buildings, affects health. It connects material production to local and regional impacts. 4. Eutrophication. Measured in kilograms of nitrogen equivalent or phosphate equivalent. This is about excessive nutrients, often from manufacturing wastewater or maybe fertilizers used for bio-based materials getting into water bodies. It leads to algal blooms, oxygen depletion, dead zones, bad for aquatic life.
Algal blooms, right.
5. Formation of tropospheric ozone. Measured in kilocharns, teratrace O3EQ, or kilotraethene. This is about ground-level ozone smog. Unlike the good ozone up high, this stuff is a harmful pollutant, a respiratory irritant, damages crops, linked to emissions that impact local air quality.
Smog. Got it.
And 6, depletion of non-renewable energy resources. Measured in megajoules, MJ, using methods like CML or depletion of fossil fuels using TERIA-CI. This focuses on how much finite stuff we're using up: fossil fuels, minerals. It's not just about emissions, but resource sustainability for the future. Pushes towards circular economy thinking.
Wait, GWP, ozone depletion, acidification, eutrophication, smog, resource depletion. That's a lot more than just carbon.
It absolutely is. So as you can see, a WBLCA under option 1 is not just a simple carbon calculation. It's a comprehensive environmental audit of the materials. It forces projects to look at this wide range of impacts and make truly informed decisions, avoiding those unintended consequences.
So designers need special tools for this.
Definitely. Designers need specialized LCA software tools like Tally, One-Click LCA, Athena Impact Estimator are common ones, and they need the expertise to run the models correctly and interpret the complex data that comes out. It's a significant investment in time and potentially cost, but the insights it yields are unparalleled.
Wow, that is incredibly thorough. And I imagine managing that level of detail across 6 different impact categories presents a significant data challenge. Finding all that information must be tough.
It can be, yeah. Data availability and quality are definitely key challenges.
So for a project that might not be ready for that full-scale environmental MRI, or maybe wants to complement it with something more focused, how do EPDs offer a different yet still powerful approach? That's option 2, right?
That's a great question, and it leads us perfectly into option 2. It offers a more granular, material-specific approach that can complement a WBLCA or even serve as an alternative way to earn points. If WBLCA is the wide-angle panoramic view, EPD analysis is like zooming in with a telephoto lens on individual components.
Okay, zoom lens, I like that. So what exactly is an EPD?
An Environmental Product Declaration, or EPD, is essentially a standardized, transparent, and independently verified report. It communicates the environmental performance or impact of a specific product throughout its life cycle, or parts of it.
Like a nutrition label.
That's the classic analogy, yeah. Think of it like a nutrition label for building materials. Instead of calories, fat, and sugar, it details environmental metrics like global warming potential, water usage, ozone depletion potential, etc., usually following a standard methodology like ISO 14025.
Standardized and verified. That sounds important.
Crucial. And LEED EV5 specifically calls for product-specific or facility-specific Type 3 EPDs. This is key because it ensures the data is robust, reliable, and directly attributable to the exact materials being used in the project, not just some generic industry average. It's about getting real, actionable data for the specific products you're actually specifying and procuring.
Okay, so option 2 uses these EPDs. How many points can you get, and how does it work? You said there were paths.
Right. Option 2, EPD analysis, offers up to 3 points in total, and it provides 2 distinct pathways for projects to leverage this material-specific insight. Path 1 is the project average approach, offering 1 to 3 points.
Project average. So this path focuses on the project's overall material choices compared to the broader industry. How does that work in practice? What kind of reductions are we looking for?
Exactly. With Path 1, a project earns points by demonstrating a reduction in the embodied carbon of its entire project, specifically looking at the applicable structural, enclosure, and hardscape material categories where they have EPD data. They compare the performance based on the specific EPDs for the materials they actually procured against industry average values for similar materials.
So you gather all your EPDs, calculate the total GWP.
Right. You calculate a weighted average GWP for your project based on the quantities and the EPDs of the materials used. Then you compare that aggregated value to what a typical project using similar materials in that region might achieve based on established industry benchmarks.
And the points depend on the reduction.
Just like with the WBLCA, the points awarded are directly tied to the percentage reduction in GWP compared to that industry baseline. For example, maybe a 10% reduction earns 1 point, a 20% reduction earns 2 points, and achieving a 40% or greater reduction gets you the full 3 points available under this specific path. It incentivizes optimizing a broad range of material choices across the whole project.
Where do those industry averages come from? That seems critical.
Absolutely critical. They need to be credible benchmarks. LEED specifies they should come from highly reputable sources like the U.S. Environmental Protection Agency, EPA, the most recent Carbon Leadership Forum, CLF, Material Baselines Report, or similarly robust and widely recognized publications, and industry-wide EPDs applicable to the project region.
So established, trusted sources.
Exactly. This ensures that the benchmarks are current, scientifically sound, and regionally appropriate, providing a fair and accurate comparison. It stops projects from comparing against an outdated or irrelevant baseline just to look good. It ensures the reductions are meaningful relative to current market norms.
Makes sense. What about tracking and changes during construction? Same 10% rule.
Yes, similar logic applies. For Path 1, projects must track the GWP unit of the materials installed. This means keeping meticulous records tying every significant material going into the building back to its specific EPD and its GWP value. If there are changes to materials or their associated GWP values after the initial design phase, maybe a specified product wasn't available, and they had to substitute, teams need to reconcile those design phase embodied carbon intensities to ensure the final calculation reflects what was actually built.
But the quantities?
Right, the quantity reconciliation follows the same principle as WBLCA. It isn't necessary unless those quantities have changed more than 10% from design through construction. This provides some practical flexibility for minor adjustments. The emphasis remains on using project-specific material quantities and those verified product-specific or facility-specific Type 3 EPDs.
Got it. You also mentioned biogenic carbon earlier, the carbon stored in wood. How does that fit into EPDs?
Right, that's an important clarification here too. For biogenic carbon, the carbon stored in biomass like wood, bamboo, agricultural products, used materials, LEED V5 states, it may only be included for calculations that include C-stage emissions.
C-stage, end of life. Same rule as WBLCA.
Exactly the same rule. Wood stores carbon while it grows, which is great. But if that wood is eventually incinerated or decomposes in a landfill at the end of the building's life, that stored carbon can be released back into the atmosphere as CO2 or methane.
So you have to account for the release, too.
Precisely. LEED-V5 ensures that if you're taking credit for the temporary storage of biogenic carbon, Module A, you also have to account for its potential release at end of life, Module C. This gives a true net impact over the full life cycle and prevents an overly optimistic picture, especially for materials like timber. It enforces that full life cycle perspective.
That seems fair and scientifically sound. Okay, that's Path 1, the project average. What about Path 2? The materials type approach, you said 1-2 points for new construction.
Correct. Path 2 offers 1 or 2 points.
Is this a more targeted way to get points? Like focusing on specific material categories where you've really made improvements? Picking your battles, maybe?
Precisely. That's a great way to put it. Path 2 allows projects to earn points by demonstrating that specific structural, enclosure, or hardscape material types have lower embodied carbon impacts compared to their relevant industry benchmarks.
So instead of averaging the whole project, you focus.
Right. Instead of a whole project average, you might focus specifically on, say, your concrete mix design across all concrete used, or your chosen insulation type, or maybe your steel sourcing. You show that those particular material categories perform significantly better environmentally than the industry standard.
Still using EPDs, I assume.
Absolutely. You're still relying on robust, product-specific Type 3 EPDs for this detailed data. And just like in Path 1, projects need to track the GWP per unit of the installed materials within those targeted categories and reconcile the design phase intensities if the GWP values change significantly. The same 10% quantity change thresholds for reconciliation also applies here.
Can you average within a category? Like if you use a couple of different concrete mixes?
Yes, that's allowed. The guidance mentions that a weighted average approach can be used to calculate average embodied carbon intensity values within a product category. So if you're using several different types of concrete with different EPDs, you can calculate the weighted average GWP for all your concrete and compare that average to the industry benchmark for concrete. It provides practical flexibility.
And the benchmarks are the same, EPA, CLF.
Correct. The sources for industry averages remain the same reputable ones: US EPA, CLF material baselines, and other recognized publications or relevant industry-wide EPDs. Consistency is key there.
Okay, that's a great breakdown of the two EPD paths. Both rely heavily on having those verified EPDs from manufacturers, which seems like it could be a challenge in itself.
It definitely can be. The availability of high-quality product-specific EPDs is still growing, though it's much better than it was even a few years ago. This credit really pushes manufacturers to invest in transparency.
So strategically, what's the key difference between Path 1, project average, and Path 2, materials type? Why might a project team choose one over the other?
The strategic difference really comes down to scope, where the project's main efforts lie, the data they have access to, and where they are best positioned to demonstrate significant reductions. Path 1, the project average approach, takes that broader, more holistic view of materials across the board. It's ideal for projects that have implemented a comprehensive strategy to reduce embodied carbon across many different material categories, structure, enclosure, maybe even hardscape.
So if you've optimized everywhere.
Pretty much. It rewards that comprehensive strategy of material optimization for the entire building scope covered by the credit. It also offers a slightly higher potential point yield, up to 3 points, which can be very attractive for projects with well-developed, wide-ranging material strategies and good EPD coverage.
Okay. And path 2?
Path 2, the material type approach, is more targeted, as you said, picking your battles. A project might choose this if they've made really significant strides in optimizing the embodied carbon of specific high-impact material categories, but perhaps haven't been able to do that across every single material used.
Like maybe they focused heavily on the concrete.
Exactly. For instance, they might have innovated with a very low-carbon concrete mix that dramatically reduces the GWP of their structural system, which is often the biggest chunk of embodied carbon. But maybe their exterior cladding choices are more conventional, or perhaps EPDs just weren't available for certain niche products they needed to use.
So path 2 lets them get credit for that specific concrete innovation.
Right. Path 2 allows them to highlight those specific areas of excellence and gain points for those targeted improvements. It offers 1 to 2 points, so slightly fewer maximum points than Path 1, but it provides valuable flexibility. It lets projects showcase impact where it's most pronounced or where their innovation efforts were concentrated.
So path 1 is about the sum of the parts across the project, while path 2 lets you highlight particularly high-performing parts within specific categories.
That's a perfect summary. Both paths, however, strongly encourage leveraging transparent EPD data to make informed, impactful material choices. And as you noted, the availability of those EPDs from manufacturers is often a practical driver here, pushing designers and specifiers to favor products from companies that have invested in providing this environmental transparency.
That distinction is really helpful. It gives teams realistic options depending on their strengths, the EPD data they can actually get their hands on, and where they can make the biggest provable impact. Now, we've focused a lot on the materials themselves, their extraction, manufacturing, transport, replacement, disposal, the stuff in the building. But what about the actual act of building it? Does that generate emissions that LEV5 addresses here, or is that considered something else outside the scope of embodied carbon?
That's an excellent question. And yes, LEV5 absolutely addresses it within the same credit area. This is where option 3 comes in. Track carbon emissions from construction activities. This offers an additional 1 or 2 points.
Ah, so it is part of this credit.
It is. This option broadens the scope beyond just the carbon embedded in the materials themselves, to include the emissions generated by the actual process of construction on site. It recognizes that how we build is also critically important, not just what we build with.
Okay, so what module is this in LCA terms?
This option specifically focuses on LCA Module A5. Within the Standard Life Cycle Assessment Framework, Module A5 is designated for the construction and installation process.
Got it. A5 equals construction site activity.
Exactly. So this isn't about the carbon footprint inherent in the steel beam or the concrete mix itself. It's about the fuel burned by the excavators and cranes bringing those materials to the site and putting them in place. It's about the electricity used for temporary site lighting, running site offices, maybe charging electric tools. It includes fuel for site heating or cooling, temporary facilities. Essentially, all the operational energy expended during the build phase itself. It's the on-site carbon footprint of construction.
Okay, so how do you get points for tracking that?
There are 2 pathways under option 3, reflecting different levels of tracking, commitment, and control. Path 1 offers 1 point.
And what does that require?
Path 1 requires projects to track all fuel and utility usage for contractor job site operations.
The general contractor.
Yes, primarily the general contractor's direct operations. They need to meticulously monitor and report the energy consumed on site that's directly under their control. This would typically include things like diesel fuel for their heavy machinery, gasoline for smaller equipment or vehicles, electricity drawn for temporary site offices, lighting grids, tool charging stations, and any natural gas or propane used for site heating, material drying, or temporary amenities.
So it incentivizes the main contractor to be more efficient.
Exactly. Use more fuel-efficient equipment, optimize their logistics to reduce truck idling, minimize waste heat, maybe use LED temporary lighting. It pushes them to manage their direct operational footprint.
Okay, that's 1 point. What about path 2? You said it offers 2 points.
Right. Path 2 offers 2 points, and it requires a significantly more comprehensive approach. For this path, projects must track all fuel and utility usage for contractor and subcontractor job site operations.
Bringing the subs into it, that sounds complicated. This raises an important question. Why does tracking subcontractor emissions make it worth an extra point? It seems like potentially a lot more administrative work, almost like herding cats on a busy construction site with dozens of different companies coming and going.
You hit the nail on the head with herding cats. It is indeed significantly more work, requires much more coordination, and that's precisely why it earns that extra point. Tracking just the general contractor's direct fuel and utility use is a good start, but let's be honest.
Yeah.
On most large, complex construction sites, subcontractors often operate a significant portion, maybe even the majority, of the heavy equipment and consume a substantial amount of the total site energy. Think about the specialized equipment needed for deep excavation, for concrete pumping and finishing, for erecting steel or precast panels, installing complex facade systems, paving, intricate mechanical and electrical work. A lot of that specialized energy-intensive work is done by subcontractors.
Right. The GC might not own all that specific gear.
Exactly. So including the subcontractor's emissions reflects a much deeper level of commitment and, ideally, control over the entire job site's carbon footprint. It requires much more extensive data collection, getting fuel receipts or meter readings from potentially dozens of different entities. It demands rigorous coordination, clear communication, and often it needs to be written into the subcontracts up front to ensure all parties are obligated and equipped to report their energy usage accurately.
So it needs a more sophisticated management system.
Absolutely. Strong communication channels, maybe even using technology like telematics systems installed on heavy equipment to automatically track fuel consumption and operating hours. It signifies a more rigorous and truly holistic approach to managing construction phase emissions. It pushes project teams to engage the full ecosystem of the construction process in their carbon reduction efforts, not just the GC slice. That extra effort and broader impact is why it's worth the additional point. It's a powerful incentive for more integrated project delivery where sustainability is shared responsibility.
So stepping back, what does this option 3 really mean for building teams on the ground? It sounds like it's fundamentally changing the conversation on the construction site itself. It's not just about picking green materials anymore, but also about how you actually put the building together. The process matters just as much as the product.
Exactly. That's the perfect takeaway. Option 3 connects directly to the practical realities of construction management and transforms the job site itself into another crucial arena for sustainability performance. It encourages building teams, GCs, and subs to think deeply about efficiency and sustainable operational choices during the entire build phase.
Like what specifically?
Are they using the most fuel-efficient machinery available? Are there electric or hybrid options for certain equipment, like excavators or lifts? Are they optimizing site logistics and material delivery schedules to minimize unnecessary transportation emissions to, from, and around the site? Are they reducing equipment idling time through better planning or auto-idle technology?
What about power?
Are they leveraging renewable energy sources for temporary power where feasible? Maybe using portable solar generators for site offices or charging stations instead of just diesel generators all the time? Are they minimizing energy waste from temporary heating or lighting?
So it's about operational efficiency during construction.
Precisely. It's about minimizing energy waste, optimizing schedules, adopting best practices that not only reduce carbon, but interestingly, can also lead to significant cost savings through reduced fuel consumption, better material management, and increased overall site efficiency. This credit ensures that the commitment to sustainability isn't just something documented on paper back in the design phase, but is actively implemented, measured, and managed throughout the physical construction of the building. It turns the entire construction process into a tangible opportunity for carbon reduction.
This has been an incredibly detailed look at how LEV5 is tackling embodied carbon. We've covered a lot of ground, from the big picture WBLCA to the specific EPD analysis, and now the construction activities themselves. It really provides multiple nuanced pathways for projects.
It does. It offers flexibility while maintaining rigor.
So, as we try to connect all these dots, what does this all mean for you, our listener? Whether you're involved directly in construction or design or manufacturing, or maybe you're just curious about how we build a greener future. How do all these options, option 1, 2, and 3, fit together strategically for a project team trying to navigate this?
That's the key question, isn't it? How do you put it all together? I think it means we're at a really pivotal moment in green building. These LEED V5 requirements aren't just rules. They're providing clear, actionable pathways for projects to make a real, measurable difference on embodied carbon. Synthesizing all this information, we can see that project teams now have a strategic array of choices. They can tailor their approach to maximize their points and, more importantly, their overall environmental impact reduction.
So let's recap those choices.
Okay. The whole building lifecycle assessment, option 1, is undeniably the most comprehensive route, the full MRI, as you called it. It offers the highest potential points, up to 6, for that deep, multi-impact assessment, scrutinizing the entire cradle-to-grave journey across those 6 environmental categories. It demands robust, comprehensive data and analysis, and requires demonstrating significant, verifiable reductions compared to a baseline.
High effort, high reward.
Exactly. It's a demanding path, often requiring specialized consultants and software, but it yields unparalleled insights and rewards projects committed to leading the way with a truly holistic vision. It's probably best suited for the truly ambitious projects aiming for top-tier certification. Then we have EPD analysis, option 2, which provides that more flexible, material-focused approach. The zoom lens.
Yep.
With its 2 distinct paths, projects can either take a project average approach, path 1, comparing the overall embodied carbon of their procured materials against industry averages for 1 to 3 points, or opt for a materials-type approach, path 2, targeting specific material categories where they can demonstrate lower impacts for 1 to 2 points.
More flexible, maybe more accessible for some.
Potentially, yes. This flexibility allows projects to focus their efforts where they can achieve the most impactful reductions based on their specific design constraints, the availability of materials with good EPDs in their market, and their supply chain relationships. It's a great stepping stone towards full WBLCA, or a very effective focus strategy in its own right. And finally, tracking construction activities, option 3, offers those additional points, 1 to 2, by focusing on the operational emissions generated during the building process itself, on the site.
Right, module A5.
Exactly. This complements the material focus efforts by encouraging efficiency and sustainable practices right there on the job site, from fuel use to temporary power. It extends the reach of sustainability directly into the hands-on building phase.
Okay, so you have these 3 main options with different pathways within them. Can projects mix and match?
Yes, and that's what's truly powerful here, and a point of really clever design in the LDV5 credit language.
Yeah.
It uses and/or logic.
Ah.
Meaning this isn't an either situation where you pick just one option. Projects are explicitly encouraged, and often it's strategically beneficial, to combine strategies from options 1, 2, and 3 to maximize their points and their total environmental impact reduction.
So you could do a bit of everything.
Absolutely. A project might, for example, do a comprehensive WBLCA, option 1, just for their structural system, where the impact is highest. Then they might use the EPD approach, option 2, path 2, for specific enclosure materials where they found particularly innovative products with great EPDs. And on top of that, they could diligently track their construction site emissions, option 3, maybe path 2 for extra points, for a truly holistic approach.
That sounds like a really integrated strategy.
It is. It allows for a tailored approach that optimizes both the design choices and the construction phase practices for reduced embodied carbon, reflecting the real-world complexity and opportunities within building projects.
If we connect this to the bigger picture then, what does this mean for the industry? Are these LED requirements actually driving change?
Oh, absolutely. These LDV5 requirements are poised to be a huge driver of innovation throughout the entire construction supply chain. This isn't just about earning points for a plaque on the wall. It's fundamentally reshaping entire industries.
How so?
We're already seeing manufacturers of steel, cement, concrete, insulation, glass, you name it, actively investing in developing and promoting new low-carbon technologies and products. Think electric arc furnaces for steel production using renewable energy, novel geopolymer or alternative cements that drastically cut process emissions, advanced bio-based insulations, higher recycled content in everything.
And they're doing this because of LED?
Partly, yes. They're doing it not just because it's inherently good for the planet, though many are genuinely committed, but because standards like LEB5 are now creating a tangible, strong market signal for these lower embodied carbon products. Architects and designers seeking LED points will specify them. It creates demand. It's becoming an economic incentive for innovation, transforming what was once maybe a niche environmental concern into a real competitive advantage in the marketplace.
So it's pushing the supply side.
Definitely. And this ripple effect extends to policy as well. We're seeing more and more cities, states, even federal agencies starting to adopt embodied carbon limits or reporting requirements for public projects, often looking to the methodologies and benchmarks pioneered in green building standards like LED as a model. It's creating a kind of race to the top for more sustainable materials and practices.
That's really encouraging. It feels like a systemic shift.
It really does. And my core belief, is that knowledge is most valuable when it's understood and applied. Understanding this credit, MRc2, empowers you whether you're a developer looking for market differentiation, an architect specifying materials, an engineer optimizing a structural design, a contractor managing a job site, or even just an informed citizen or student interested in greener infrastructure.
Yes.
It empowers you to ask better questions, to push for more sustainable outcomes in any project you encounter or support. It gives you the language and the framework to understand what truly sustainable building looks like in the 21st century, beyond just operational efficiency.
Asking better questions. That's powerful. What an incredible deep dive into LEED's MRc2. We've really explored the critical growing role of embodied carbon, understood the comprehensive, holistic approach of whole building life cycle assessments across those 6 impact categories.
Not just carbon.
Not just carbon, exactly.
Yeah.
We delved into the granular insights provided by EPD analysis for specific materials, and even looked at how tracking the emissions from construction activities themselves contributes to a greener build. It's crystal clear that this new credit offers multiple, flexible, and powerful pathways for projects to significantly reduce their environmental footprint. It feels like it's truly pushing the industry forward.
And this commitment to comprehensive assessment and reduction really is transformative. It tells us that the journey to truly sustainable building isn't just about what materials go into a structure, but about how every decision, from the earliest design concepts and material sourcing choices through the final stages of construction, and even considering the eventual deconstruction and end of life, how all of that impacts our planet. So maybe the final thought is this. What new questions will you ask about the materials and processes behind the buildings going up around you now that you know more about the hidden story of their embodied carbon?
A fantastic question to leave our listeners with. We hope this deep dive has given you a clearer, more nuanced picture of how we can build a more sustainable future, one material, one process at a time. If you found this insightful and you want to keep exploring the fascinating world of sustainable practices and crucial global developments like this, don't forget to subscribe to hear more about this world.